we are gonna finish the rest of these questions, of course, from the suggested problems. I think last night someone sent me a suggested problem that is something we were gonna do anyways. Yeah, number 47. Let me just make sure that that's right. Let me see. Here, this person. Yeah. Okay, we're good. So, any questions before I start? We're gonna start with number 36. Okay, I'm just getting the textbook open. So we are in chapter 17, number 36. Right? 36. Yeah. So, oh, it has two different parts. Oops. Okay. There. Okay. So the question is, a 2-meter long wire having a mass of that is fixed at both ends. The tension in the wire is maintained at that. So we know the speed of the wave in the wire, right? Because it gave us the mass and the tension and the length. So essentially that first sentence is just giving us the speed. What are the frequencies of the first three allowed modes of vibration? It's fixed at both ends, so it's going to have normal harmonics. If a node is observed at a point that... Okay, well, let's start deal with part A first. So what are the frequencies of the first three allowed modes of vibration? Well, it's just the first harmonic, which is going to be V over 2L. The second harmonic, which is going to be V over L. And the third harmonic, which is going to be 3V over 2L. Right? Does that make sense? I just did a little canceling on this one here, but yeah. V over L. Okay, so remember that V is the square root of the tension over the mass density, which we know both those things. Tension is 20 newtons, and the mass density is 0.1 kilograms per 2 meters, which is going to be 0.05 kilograms per meter. Right. Okay. So what are the frequencies? Well, we just plug it in, right? So we just say that F1 is the square root of the tension over the mass density over 2L, which is something we can plug in. Here we do the same thing. The square root of the tension over the mass density over L, and it said the first three, right? Yeah. And then the next one is 3 square root of V over of T over mu over 2L. I have a feeling something more complicated is about to happen, so let's see what we get as numbers here. If something else happens, then we do it. If not, it's just a very simple question. So the first one is 20 over 0.05 over 2 times 2. So I got 5 hertz. Okay, the next one is 20 over 0.05. Oops, no, that's not what I meant to do. 0.05 over 2. So I got, well, actually I could have done that in my head, but yeah, this is 10 hertz, and probably the next one will be what we're expecting. So 20 over times 2 times 2 and 3 times. I got, yeah, 15 hertz. Is that it? I don't have the answers in the book, so I don't know, but I don't see why any of those wouldn't apply. So yeah, that makes sense to me. The first harmonic, second harmonic, and third harmonic. Okay. If a node is observed at a point that many meters from one end, in what mode and with what frequency is it vibrating? Okay. Well, so the wave is fixed at both ends. First of all, it's fixed at both ends, which means the ends are nodes, right? So if I have this, I want to be the third harmonic. So this would be the third harmonic. 1, 2, 3. That's the third harmonic. So, not for any reason. It's just for the picture. I don't know if it's going to be the third harmonic. Essentially, what it's saying is that this distance here is 0.4 meters, right? Because there's a node. The next node is 0.4 meters in. Well, it doesn't say the next node, but it says just a node. But since we're only in the first, second, or third harmonic, it's just the next node. So, in what mode and with what frequency is it vibrating? Well, this is going to be half a wavelength, right? This is half a wavelength. So I want to know for which mode is 0.4 meters half a wavelength, or is 0.8 meters one full wavelength, right? Well, V equals lambda f, right? We know V is constant. Lambda is what we're looking for. We know F for each situation here, right? So if I just divide it by F, I can find lambda, and I want to know which lambda is 0.8. This is half a wavelength. I want to know which wavelength is 0.8, which is twice as much. So let's just try it. For F1, we get lambda 1 is V over F1, right? Which is, I'll just plug it in. Lambda 1 is, so it's going to be, it's too late now, but I should have just kept V as a constant. F1 is 5. So I got 4 meters. So F2 will get us lambda 2, which is V over F2. Lambda 2 is 10, just 2. So I won't get, oh, maybe I will get what I'm looking for. 2 meters. And hopefully lambda 3 is the one that gives it to us. And if not, then we have trouble. F3, which gives us lambda 3, is V over F3. So lambda 3 is V over 15, which is 1.3333. Okay, which is not what we're expecting. 1.333 meters. That one's 15 hertz on the end there, right? So, oh, maybe it doesn't have to be. Yeah, maybe it doesn't have to be that. Actually, you know what? We can solve for.
We know the wavelength. If it's 0.4 meters between each node.
Yeah. Okay. So we don't actually have to do this
Just
trial
solve
and
for
guessing,
the frequency.
or solve for.
Because we know V. V doesn't change.
Yeah, that makes more sense actually. If a node is observed at point what mode and with what frequency is it vibrating, and then we just solve for n with that frequency to find the mode. Yeah. So I may as well actually just write this. Yeah, I realize now. So none of the first 3 harmonics is what it was. And so yeah, so now we're gonna have to do something a little different. I'm still gonna use the fact that V equals lambda. Oh, I keep writing the wrong. Lambda F, but F is some nth harmonic that we don't know. So that tells us that V equals lambda. May as well just solve for n right away. NV over 2L, right? I want to know what n is, right? I want to know which harmonic we're on. So I can just solve for n now, right? V's were constant anyways, but I guess they don't matter. Then lambda is a constant, L is a constant. We just solve for n. So it's just going to be 2L over lambda equals n. So that gives us 2L is 4. 4 over lambda. Lambda was 0.8. So I got 5. Right? Lambda is 0.8 because half a wavelength is 0.4. So we got 5. So the fifth harmonic is what's going to give us the distance there. And to find what frequency that is, well, we just do F5 is 5V over 2L, which is 5 times 20 over 0.05 over 2 times 2. So I got 25 hertz. Yeah. Okay, good. We got the answer. I don't know why I assumed at first that it would be one of the first 3, so I just thought I'd guess and check, but yeah, there's no reason to assume that. My T. Okay, any questions about this one? Fifth harmonic, 25 hertz. Okay, 42 is our next one. So here, 2 speakers are driven by the same oscillator of frequency F. They are located at a distance d from each other on a vertical pole. A man walks straight towards the lower speaker in a direction perpendicular to the pole as shown in the figure. How many times will he hear a minimum in sound intensity? Okay. Well, he hears a minimum in sound intensity when... Let me find it. When
Isn't it the difference between the distances to him is lambda over 2?
I think it might be
Or like n plus.
n plus a half. Yeah, n plus a half lambda. I think that's what it is. I want to find it though, just quickly. So destructive interference occurs if... Oh, I just realized I didn't update the... I didn't take the full screenshot there. Let me... Since this is recording, I want to fix the text on the bottom here. This is from 8. Well, actually, convenient. I just switched this to AM. To 9:30 AM. Still setting session 5. Yeah, okay. I also realized that your voices are not in the recording. Could someone say something quickly? Oh, you were in the recording. Never mind. All good. Okay. So, yeah. Let me take a better screenshot of that. So, destructive interference occurs if the absolute difference between the 2 radiuses, like the distances that they're traveling, is some odd multiple of lambda, right? So, well, okay, what do we know? We know the frequency is F. We know, well, I just write it. We know for the frequency, we know the distance there, we know L, right? Does it tell us? I mean, it doesn't say a number, I know, but what variables are we allowed to use? I guess we're allowed to use L because it shows in the picture. Okay, so how do I find lambda? Well, first of all, lambda is V equals lambda. I always say writing the wrong symbol. Lambda F. So I guess we can say that lambda is V over F. V is a constant in air. I think V is 343 meters per second. I think that's right. And so we can show that lambda is just this. So, okay, now we have an expression for lambda. Well, we want that the absolute difference between the 2 lengths is going to be some odd multiple of this. Let's find these distances. So this distance and then this distance. I mean, this distance is just L because it's going straight. Right, so if I call this one R1 and this one R2, well, R2 equals L. Okay, but what's R1? R1 is, this length is L, this length is D, so it's going to be the square root of D squared plus L squared. Okay. So, let's see. The question is, how many times will he hear a minimum? So it's going to be in terms of L, I think. Well, okay, let's just use this formula. The absolute difference between L minus square root of d squared plus L squared equals n plus 1/2 v over f. Odd multiples of v over f. What am I solving for? I'm solving for... Is it n? Is that the number of the odd multiple?
It doesn't give us f, does it?
Well, it doesn't give it as a number, but it gives it as a variable up here. So we're allowed to use it as a variable.
So wouldn't we solve for n? It's like, do we just assume f is a constant?
Yeah, it's constant. F is constant. F is constant. So just solve for n, you think?
I guess.
Yeah. Okay. So I'll
There's like no given information for this question, so.
No, yeah, it's all gonna be in variables. So I'll just, yeah, n plus 1/2 v over f, and then I'll solve, this is case 1. And then case...
Wouldn't that give you a negative, though? For that scenario? If you do L minus the square root of L squared plus D squared.
Would it?
Wouldn't D squared plus L squared always be bigger than L?
Yeah, that makes sense to me. So I'll just flip these
flip
around.
them the other way around, though, because it doesn't make a difference.
Yeah. Okay, I guess, so then we don't have to worry about absolute value then, if the square root of d squared plus L squared minus L, we don't have to worry about the second case. If this is always going to be bigger. Yeah, it's just because there's another variable. It's just because there's another variable. I understand we're square rooting the square, so it's not going to be that much bigger, but it is going to be bigger. Because this, including the square root, is essentially L, right? Okay, a little off because of this, but this only makes it bigger. So this is definitely bigger than this, right? Yeah, okay, so we don't have to worry about the absolute values then. So it's d squared plus L squared minus L, and solve for n. Yep, I think so. So this is just square root of d squared plus L squared minus L, f over v, minus 1/2 equals n. And what is n here? N is the biggest multiple of n plus 1/2. Yeah, n is like what multiple of lambda you're hearing. Lambda over 2. What multiple of lambda? Well, yeah. I think. Let's see. 42. I'm gonna look this one up. I want to see what the...
Wait, there's a better version of this in the tutorials.
There is, yeah.
Yeah, let me check.
Well, Chegg has it, but Chegg is behind a paywall. Just looking some of the answers here. So what's D? Oh, D is the same D that we have here. Trying to find this. Let n and max be the number of times you overhear the moves.
I sent the question on discussions.
Sure. Thank you. Thank you. Which is essentially the same question. Oh, but they do give actual numbers in this one?
Yeah.
Yeah. Well, this is doable in terms of variables too. It's just a little weird. I can.
Is this just one of those questions where they ask you to find an equation that would give you, like, the number of times that, like, he hears this or that? It's not necessarily like you're trying to find the actual answer.
Yeah, I think so. I think so because the answer online is not a number; it's an expression. And also, we have no numbers, so nothing we can. There's no.
Do we just go on then from that? Just
Well, I guess let's try the tutorial question then. It's the same thing but with numbers. And let's see if we can figure this one out because I think it'll be a little easier because of the numbers. Let's try it here. So two speakers are driven same thing. They have a frequency of 100 hertz. They're located D is 10 meters on the vertical pole. Man walks straight to the lower speaker in a direction perpendicular to the speed of sound in air is 343 meters per second. Okay. Call R1 the distance from the man to the lower speaker and R2 the distance from the man to the upper speaker. Write an equation for the path length difference in terms of variables given in the problem. Well, I already did that. So delta R equals this one. Square root D squared plus L squared plus or minus L, or why was it minus L? Yeah, minus L. Yeah. Another reason we know that we know this length is longer than this length, right? So we know that this will be bigger than this, so the absolute values don't matter. Okay, that's for part A. Then, using your formula from the previous part, if L is very large, is the path length difference large or small? So if L is very large, then the path length difference is very small because, so okay, as L gets bigger, right, D becomes more negligible. Eventually, it's just the square root of L squared, which is just L, so L minus L is 0. So the limit as L goes to infinity is 0. I didn't prove it or anything like that, but that's the idea. So, yeah, very small because that. Okay, and mathematically, what is the largest possible path length difference? Well, I guess L is 0. So if L is 0, it's just, no, that doesn't make yeah, actually, no. If L is 0, then this path length is 0. This path length is D. Although I don't know if that's the answer. Just because of this limit, I'd say it's when L is 0. I don't know if, like, what about over here? No, the path length difference isn't that much. For some fixed values. Yeah. So I think it's when L is 0. Do we have the answers for this one?
We don't have the answers for A to C. I sent parts D and E.
Okay, thank you, yeah. So I don't know if this is the correct answer, but I'd say when L is 0. When L is 0. Again, because when L is 0, this distance is 0, this distance is D. I think that's the largest difference of path lengths that you'll see. So, okay. Let's take a look at the next one. So if the man starts very far, can I get a better? Is this higher quality? Yeah, I don't know why that first one. I think I just grabbed it out of the chat. So if the man starts very far away and walks towards the loudspeaker, how many times will he hear a minimum in the sound intensity? Compare the maximum possible path length difference to the wavelength. So how many times will he hear? Again, we need this formula, right? Well, I'll leave it here. I guess I'll just get another copy of it.
do we use the equation we made from last question or find N?
Is N what we're looking for?
Well, we would be comparing the maximum possible path length difference to the wavelength.
Yeah, I guess so. For the maximum possible path length difference to the wavelength. Yeah, find the man. If the man starts very far away, how many times will you hear minimum in sound intensity? Minimum occurs here. Compare the... Okay, so maximum possible path length is when
it just D?
Wait, no, that doesn't make sense then.
We said L is 0.
Wait, maximum. Compare the maximum possible path length difference.
That's what we did for question C.
Yeah. But. Yeah, because as you go further away, the path length difference is small. Yeah, because they're almost the same length. The D becomes negligible. But as you're really close, yeah, that makes sense to me. When L is 0.
Oh, we can find the waveform, can't we? We have V and we have L.
Yeah, we can find.
So then, do we just compare like how many times will it happen as he just keeps walking away?
343 over 100. Is that what it was? 343 over 100. Yeah. Okay. Which is 3.43 meters. So. Maximum possible path length difference.
We can see if D, the length of D, would give us a destructive or constructive experience.
But how would that answer the question? How many times will he hear?
We would know what the interval of distance is between each node or antinode.
So if I start here, if I just say D equals n plus a half lambda, and see if this is an integer.
Well, isn't the distance between each node the same amount? Like the distance between each destructive node, like this, it's the same distance between each one.
Yeah, it's not the same
path length difference between each one. I guess the same multiple of the path length difference.
Let me see for a second. I don't think this will be. Let's see. So D over. Do we know D? Yeah, we know D. D over lambda is n plus a half, so minus a half equals n. So, well, it won't be a integer. It'll be 10 over 3.43 minus a half equals n. 3.43 minus a half. Yeah, no. So I got n is 2.415, which isn't an integer. So compare the maximum possible value. Do we have answers for this or no? Are there no answers for this? This one. Oh, we are at 50 people. Maybe is there someone else who could stream?
Give me a second.
Yeah, could you? Thank you. Is this the answer? Oh, yeah.
It's a similar question. It's like the first one you did with it has no variables, but it has the status set.
Yeah. Therefore, so yeah, they're finding a expression for. Let's see. Okay, they're doing a little mathematically here, but let's see if I can understand. From 1 we know S that 0. The difference is between 0 and D. Yeah, which is what I said. For all x1 is greater than 0. Yeah. Yeah. This and 2 tells us that there is a maximum value for n which observes minima. To get that n, we solve the inequality. So what they do in the solution is they solve the inequality, which is 2n minus 1, which is, I assume the same thing as that. If I just multiply by 2 over 2, 2, not quite the same. Multiply just the tops. They factor out lambda over 2 is less than or equal to d, which is this distance here, and then solve for n. But why? So I think this is the same expression as here. Let's see if I factor out a 2. Yeah, if I factor out a 2, is that a half? Yeah. It could be plus. Doesn't matter. So this is equivalent to this. It's just with an inequality, and they factored out 2 here. So why is it an inequality? There is a maximum value for n, which we observe minima. To get n, we solve the inequality.
Is it 2n minus 1 or 2n plus 1?
It's 2n minus 1 in the solution. But since it just means odd multiple, so it's the same thing as if you did plus. It's just like which multiple you start at. So it should be minus, I guess, because for n equals 0. Oh no, for n equals 0, we want it to be plus. N equals 1, we want it to be.
Can you have n equals 0? Is there a 0? I don't think there's a 0 with, like, because you can't have 0, right?
Yeah, it just means at the source, I guess. It just means 0 wavelengths away at the source, 0 half wavelengths. It's destructive interference. Right. Okay. So it's just solve for n here, and that's the maximum, or that'll be the bound on n. What we get is that n is less than or equal to df, not like derivative, but just d times f, over v plus a half. So there's a maximum value for n here, which is this, and that is the maximum distance away. So let's figure out how many times we here, or that is the maximum number of times. Yeah, that's the maximum number of times that he'll hear the minima. I don't really understand. Maximum number of minima the man can hear while approaching the pole, yeah, is n. And we know that n is less than or equal to this. Why is d... This is...
Isn't d the maximum path length difference? Is that what they meant when they said compare? Like, the
No.
maximum distance, the maximum path length difference can be d.
This is what they mean by d, though, in the solution. This is what they mean by d
Yeah.
here. So, which is the maximum path length difference. Yeah. And so, I don't really understand how this gets us the answer, though. Like, I see the math, but I don't really understand how it gets us the answer. So, how many times will you hear the math? Compare the maximum possible path length difference to the wavelength. Well, maximum possible path length difference compared to the wavelength. We did that, but why exactly? I don't really know. I say we move on, because we got more questions to finish, but yeah. Is that good? Unless anyone has any more insight. Okay. Yeah? Question or anything?
I can't think of the reason they did that, aside from, like, maximum difference. Wavelength.
Wavelength, maximum distance. They tell us that in the question. That's why exactly that, I don't really know. But hopefully we just don't see a question like that. It's too late now to ask anyone. So.
Oh wait, that's all the 2n plus 1 times lambda over 2 is all the locations at which the destructive interference would occur, right?
Yeah.
So that's all the path length differences where destructive interferences would occur, and the maximum path length difference is d.
Yeah.
So all of the destructive interference has to occur at a distance. It has to occur when 2n plus 1 times lambda over 2 is less than d, because it couldn't be more, right? Otherwise it'd be
Yeah, it can't be more. Yeah. Less than or equal to. And so n is less than And is the maximum number of times that you would hear it? I guess.
Like those are both bound by doing R2 minus R1. R2 minus R1 maximum is D.
Yeah.
R2 minus R1 at a destructive point is 2n plus 1 times lambda over 2.
Yeah, this is the max, and this is the for destructive. Well, write that again. For destructive. And so we compare those two and solve for n. I guess. There we go. Let's try part E.
Every integer, because we know D, F, and V, and a half is a constant. Every integer below whatever that number is how many times you hear a sound. How many times you hear a destructive integer.
The next integer lower is the.
Yeah, like yeah.
At a distance D, or no, at a distance.
At any doesn't we're not distance isn't
Yeah.
relevant. It's just like any n value that's less than or equal to whatever the right side's equal to is that would be one destructive interference like that occurs
For that n value, yeah. For that n value, yeah. This is the max. Okay, yeah, sure, that works. Let's move on though, because we got only about half an hour left. So let's try to get more questions done. So, how far is the man from the pole at the moment he hears a minimum in sound intensity? A minimum. Well, we want to just find L for any of these n's. Let me make sure. Let me maybe manually rearrange this because I think this was including -1, but I want to use +1. So I'll just manually do this. So it's going to be 2n plus 1 is d 2d over lambda. Yeah, how did f get there? Oh, because lambda. Yeah. Then we have -1. Yeah, -1, and then divided by 2. 2. So those cancel. Lambda is, what did we say lambda was? Lambda was, where is it? V over F. So it's going to be F over V. So dF minus a half n is here. There we go. So this will be minus half. It's just because I switched the sign here. Then we have, we need to know how far is, so what distance corresponds to any one of these n values?
Wouldn't it be the max? Because it would be the closest to the pole, right?
Max, the n max would be closest to the pole?
I don't. Well, because he starts, I don't know. He said this was for when he starts from walking, like, far away.
Yeah.
Right?
Yeah.
So would that mean that, like, the last time, the maximum...
I think we need an expression for L. We need an expression for L here, right? Because it says at the moment. We need an
Would it be the lowest number? Would it be the lowest multiple of lambda or the highest multiple?
Well, I don't think we need to pick one. I think it says for any moment where he hears minimum sound intensity, how far is he? So L equals something relating to n, something relating to lambda. So we know that he is, I don't really know. I don't have an answer for this one.
We have to find that value now, because we actually know D, F, and V.
Okay.
So then we have to we can pick every integer less than that value.
So 1,000 over 343 minus a half. 1,000 over 343 minus a half. So this is 2.4. Okay, so we have integers 0, 1, and 2. So then how far from the pole at the moments where he hears it? I mean, we have a low enough point so we can just manually do it. Yeah. Is there more of a solution here? that I have minimum occurs at. Yeah, no, the answer. Oh no, this is not for the lab. This is for the original question. Okay, do we know what to do now? I don't know what to do now.
So we know all the values of n, and we know f, and we know we have to solve for L, and so we can use like f equals nv over 2L, because we know n, we know v, we don't know L, and we know f. F is constant as well.
Wait, why does f equal nv over 2L?
Sorry, not that.
Yeah.
We want to solve the one that we made for n. I think it's one of the equations we made. We might have done it for the previous question, where we have delta r equals root d squared plus L squared minus L.
Here, yeah.
Because that would have to be equal to the odd multiple of lambda. That's where you get destructive interference.
Okay, so solve 2n plus 1 lambda over 2 equals square root of d squared plus L squared minus L for L.
Yeah, because then that would mean that the destructive interference has to occur when n is at that value.
And you plug in 0, 1, and 2, and those are the three distances.
I guess, yeah.
Yeah. Okay, like this will be a little bit of time-consuming rearranging. I want to get some more questions done before we finish, so I think we should move on to more textbook questions or anything from the chat, I guess. But yeah, rearrange this for L and plug in 0, 1, and 2, and those are your three distances. Or you can just leave it in general, solve for L.
Just before you move ahead, can I just ask what was the answer to C?
For C is when L is 0. That's the largest possible path length difference, right? Yeah.
Okay, thank you.
Okay. So let's move on. The next one we didn't finish 42, but pretty much 43, which I think is also a hard one. Yeah, 43. Let me see what 40. Okay, how about let's do 47 because someone asked me in the chat to do 47, so let's try it. And I want to get that done. So here's 47. So, a 12 kilogram object hangs in equilibrium from a string with a total length of 5 meters. I guess that means all of this is 5 meters. And a linear mass density of that. The string is wrapped around a light frictionless pulley, two light frictionless pulleys that are separated by a distance of d. Determine the tension in the string. Okay, first let's just find the tension in the string. So, well, we have the net. We can think of it like there's a net force going up like this, I think, and I think this will work. I think we can just find a net force that's going in this direction and divide it by 2 because it's symmetrical. So that force, so this is the tension. Well, this is actually technically 2 times the tension, and this is mg going down. So 2 times the tension equals mg. So the tension is mg over 2. Luckily, I can actually check this.
So are we assuming that's a 45 degrees?
Wait. Wouldn't it be
Like-
the vertical component of tension? Because it's also going to have to be pulling left and right.
But we just need the we don't need the direction of it. We just need what is the tension in the string.
Yeah,
The
but the
X
tension
component
would be
also.
more than the tension. The vertical component of the tension has to be half of the mass of half of the force pulling down on the mass. But the full tension would also have a horizontal component, so it would
Oh.
end up being.
Yeah, but they would cancel out.
But they
right?
would
One
cancel
going
out.
left,
That's
one
what
going right?
yeah. But they would cancel. Like the left and right. The net tension in the x direction is 0.
But does that change the? Doesn't the tension still exerting that force regardless? If it's canceling out.
Let me see. Let me type this number in and see if it gets the answer, and if not, let me try it. So I got 58.6, but divide that by 2. I got 29.43 newtons. So I will look at the answer. Chapter 13. Oops. Chapter 13, number 47. Oh, there's no answer in the textbook for 47. That's weird.
Why is
Tech
it
people look it up.
to like? Because for the I looked up the answer.
Yeah.
It's 12 kilo. It's 12 kilogram. Wait, let me just. I'll just see. Because they just do F equals mg. They don't do like 2 T equals mg.
Yeah, I don't know if what I'm doing is right. I want to see an answer first, and then if it's right, I will explain. And if it's not, then we'll just skip it.
I'm just a little okay now. I'll ask afterwards.
Yeah, let me just see if this is the tension. Clear for total length of 5 meters.
So you're missing a factor of cos theta. That's what Chegg said.
Yeah.
But what my issue is that I feel like what you did was right, because regardless of whether regardless of whether it was a 45-degree angle or not, we can we're just doubling the tension that's going on one side.
But that doesn't. So, this is like back to PCS 211, where it's like, okay, the tension's canceling out, like it's technically pulling itself together.
Yeah.
But it's still pulling at that force. The tension, like the what do they call it? The free body diagram for the mass. While those forces cancel out, they don't cancel out if you're thinking about the string. Like the tension that's being applied in the plus x and minus x direction, it's the same amount, so it doesn't matter. But it's still being applied as a component of the full tension itself, which is why we have to have a cos.
Okay, then let's do it fully. So I have this. We don't know theta though. That's the thing. But let's see. So
they did the exact same thing you did. Just all you gotta do is
get
plug
rid
in
of
an
it.
extra cos theta. No, it's two T cos theta.
We have to find
It
theta.
should be
though.
mg.
We have to use
Yeah.
the lengths to find theta.
Yeah, 2T cos theta is equal to mg.
2t cos theta is mg cos theta. Why cos theta? Cos is gonna give me the x.
Oh, because
No, I think 2T cos theta equals to mg only.
They define the theta to be to the vertical, not to the horizontal.
Oh, okay.
So if you want to do sine theta, that works as well. That doesn't really make a difference.
Sure. I'll call this the theta if that's what they did.
Okay.
Then cos theta is gonna give us this component, vertical component. Yeah. And then so 2t cos theta equals mg.
Sounds good.
Yeah, that's what I'm essentially saying. This distance here, that net force up is equal to mg because that's the net force down. Right? And it's 2 times t because there's 2 of them going up like that. So now I can just solve for t. I can just say t equals mg over 2 cos theta. And then we don't know anything about theta, but I guess I can just say theta.
No, you can get theta as oh wait, like the opposite side is gonna be d by 2, and this side is gonna
They give
the
you
whole
rope,
string
and
is
they give
5.
you the distance of the rope horizontally. It's a triangle.
Yeah, so
You just
that's
know
2,
that
and
other 2 sides
the
of the rope are the
inclined
same.
rope is like 1.5.
This is 1.5? I can't. Too many people were talking.
No.
I couldn't. Yeah.
The inclined one.
This here.
From the pulley
Yeah,
to
that's
the
1.5.
that one's 1.5.
Why is it 1.5?
Because the whole thing is 5, and then d is 2.
D is 2.
So
And these are equal?
of the inclined ones,
Okay.
those are equal.
Okay, yeah. So this is 1.5
So that's
meters.
1.5.
1.5 meters. And this is 2 meters because the whole thing has to add up to 5. And that's 2. These are equal. So I know now that I can find this length is... Oh, is it bad bracket? This length is 1. So I can find this here. So that length there is going to be... it's going to be the square... So that length is A. Is going to be the square root of 1.5 squared minus 1 squared. Which is square root of 1.5 squared minus 1 is 1.12. 1.12? 1.12
Understanding of fractions.
meters. So 1.12 meters
Now
is...
you can find cos theta.
Yeah, so cos theta is adjacent over hypotenuse, so 1.12 over the hypotenuse is 1.5. So answer over 0.5. So I get that cos theta is 0.75 or 745. And now I can just solve for the tension. I can just say that, so 12 times 9.81 over 2 times 0.745. So I got 79 newtons. Is that the answer?
Where's the 1.12 from?
1.12? That's this,
I want to.
that's this A, this length A here.
Oh, okay.
That's that length, that's the length A there. Just using Pythagoras theorem. Right. I can't really find the answer, which is annoying.
Drag people.
Does anybody have Chegg? You can check
And the
it.
problem is that I searched it up, but they have slightly different values. But we're running the same. Sorry.
Adam, what's the question number? I think Springer posted.
47? 47?
Is that it?
And once we find that, it's pretty easy to do part B, so we're okay with part B.
Oh, you just solve for cos theta generally. Okay. So
That's
you didn't
weird.
even need to
I,
solve for the.
Mhm.
I just calced 12. So 12 times 9.8, so mass times gravity over 2 cos, 1.12 over 1.5, and I'm getting 58.8, not your 79.
Oh. 12 times 9.81 over 2 times 0.745.
Oh, because I'm just putting in cos, then 1.112 over 1.5.
Well, we don't want cosine of this. The cosine theta is equal to this. Is equal to
Adam, your answer is correct.
Oh yeah.
right? So it's just this entirely is replaced by 0.745.
Oh yeah, okay, yeah, you're right. Because I'm getting 78.7 now. Yeah.
There you go.
Yeah. All right.
This is chapter 17, right?
Yeah, this is chapter 17.
All right,
yeah.
I'll pull up the full answer. 1 second.
For the part B, the n would be 3, right?
The n is 3. It's the third harmonic. Yeah, it's fixed at both ends. So yeah, it's just you're just solving for F3.
47. Tension is 79 newtons.
Oh, okay.
And I will not say what the next one
Okay.
is, but
Good. Okay. Well, we did get it. So how did we get it? We made this equation.
So we broke up T into being tension to X and Y components, and then we made net force, and we found that
Yeah, I should be clear. This is
Y is equal to mg, and then we just rearranged to solve for T. Then we found the Y component of T. Then we just plugged it in
Yep.
using the 5-meter triangle.
and just solved for T. Yep. And we said 2 of it because it's twice. There's 2 tensions going up. If you fully write out some of the forces in the y direction equals 0, you'll get this.
Could you have used sine and less bit?
Yeah, and that probably would have been easier. I wouldn't have to calculate A here. So yeah, but that's fine.
Hey Adam, did they give us a value for mass?
Yeah, they did 12 grams. 12 kilograms, I mean.
Oh.
They gave us mass. Okay, and then part B is what frequency must the string between the pulleys vibrate to form the standing wave pattern shown in that figure? Well, we just need F3 because that's the third harmonic. So F3 is 3V over 2L. L is D. So this is going to be 3 times the tension over the mass density over 2D, because D is the length that's actually of a string vibrating. And just plug everything in. So it's just going to be 3 times the square root of 79 over, they give us the mass density 0.001. Someone's underwater. 2 times 2. So I get the frequency needs to be 210.8 hertz.
Why are you using it for the like? Why is it to F3? Like I don't understand. Why
It's
not
just
F3.
from the picture. It says looking at the picture,
Oh,
it's the third harmonic.
yeah.
Right.
Yes.
2, 3. Right. 3 antinodes. And since it says by looking at the picture, like at what frequency must the string by the pattern shown in the figure, so we know we can actually trust that that's what they're talking about. And yeah. Okay, there we go. So sum of the forces to solve for T, 2 of them. And finally for B is just solve for F3. We know the tangent. Is that right, 210.8?
This answer says 211, but
Well, that's fine.
yeah,
That's close
same
enough.
thing.
Same thing. Okay, we finished all of those, and then we did 36, 247. Okay, have we got time for one or two more? I have 48 is just this in general, which essentially I did, didn't I? Yeah, I did. That's it in general. And then this is it in general too. So 48's done. Let's see. We only have 43 and 49. So maybe let's look what 43 is, or let's look at 49. 49 is a little odd. 49 is... let's see. Maybe it's the one of the last questions of the section, so I'm surprised to see a question like it, but maybe it's more difficult than we realize. 2 waves are described by these wave functions, where x, y1, and y2 are meters and t is in seconds. Show the wave resulting from their superposition can be expressed as a single sine function. Determine the amplitude and phase angle for this sinusoidal wave. Well, looks like we just do... so they have this different amplitude, although it's just twice the amplitude, and a phase shift. A phase shift because it's a sine and cos function. So we can alternatively write this as y1 xt equals 5 sine 2 plus 2x minus 10t, y2 xt equals 2 times 5 sine 2x minus 10t. Turning a cos into a sine, I subtract pi over 2, or I add pi over 2. Let me see.
Wouldn't it work either way?
Yeah, it should work both ways.
Yeah, that's why I'm confused. There you go. I'll just add pi over 2. Okay, so now they're almost the same.
Work both ways.
It doesn't?
You shift it one way, it's going to become negative sign.
Yeah, you're right. So I need to move
Let me
it.
check Desmos real quick. I'll check Desmos.
You need to move
I
it
always forget.
I need to move it to the right, so it needs to be minus pi over 2. Yeah.
Yep, you're right.
Minus pi over 2?
Wait, what's wrong with plus pi over 2?
You would, like, imagine this is the cos wave, this is the sine wave. I have to move this pi over 2 that way, right? If I move it pi over 2 this way, it'll be exactly out of phase. Like, it'll be exactly half out of phase from it.
Alright. Thanks.
So write this as a sum. So I think I can... The 2 is messing me up a little bit. They don't have
It's
this...
just like the first one for combining 2 waves of the same frequency. Not the same amplitude though.
Right, that's why the 2 is messing me up.
Do you just multiply them together anyway? Or do you add them together? Because it's 2a for like the general equation. So would you just do like 2.5? 2.5 plus 5?
I'm looking at my wall of...
That's 2 times 5, not 0.5.
Yeah, that's 2 times 5. That's 2 times 5.
Ah, okay.
Yeah.
I think 2 times 2a would work. I think that would work.
2 times 2a?
Yeah.
What do you mean?
Because like if we assign 5 equals a, the general equation would be a plus a is 2a, but since we have 2a already, I think it would just be 2a and then 2a again. So we'd get 5 5 times 2 times 2 again.
Yeah, at the end there. It's just that they don't have the same amplitude. So I don't think we can just jump right to there. Yeah.
I think we might. I don't know. Maybe.
If I try to add these, y1 xt equals 5 sine 2x minus 10t plus 2 times 5 sine 2x minus 10t minus pi over 2. So I can factor out of 5, of course. I'll just do it like this. I can factor out of 5. Is there an identity for 2 sine something?
Yeah. That's 2 sine x cos x will equal sine 2x.
I'm trying to find it here.
Let's try this way to see if it works. But the answer to this is it's done a different way, and it's kind of a weird way. So let's do it this way first and see if it works.
Well, I don't really have anywhere to go now. There are formulas for 2 sine, but it's not just 2 sine that I can see, unless someone knows one. 2 sine.
If you want to check homework help, I sent what Springer said.
Okay, that's it.
It's a weird question though.
Yeah, just go on the internet and search for Fred.
So this is Springer's answer? Okay, he says this is a fairly tricky question. So someone's not muted. Could they mute? Okay. Abdul.t, could you mute? Abdul.t. And someone's got organic chemistry tutor going. Okay, we're good. Thank you.
Yo, my bad.
Don't worry. So start with the expression below, which is for the total combined wave written as a single sine function. Okay, that's this. And now use the angle addition formula, sine a plus b with a equals that and b equals that. So we get here. Now this looks like the sum of a sine and a cosine with different amplitudes. Yeah, so we need to set the two amplitudes, those things. From here you can determine a, phi, since you know a1 and a2, two equations, two unknowns. Yeah. So we need to find, k and w, k and omega are the same as k and omega from the question. Here we just need to find what a and phi is from this. Does that make sense? I think this explanation is pretty good. Right, so you go backwards from, this is our target. We want to use the, sum addition formula for sine of something. And we get this out of it. We can show that this is, right, this is a some amplitude times sine of something plus some amplitude times cos of something, which is essentially what we have. I just switched it to a sine, but I could just say this is cos of something. I thought it would be good to switch it to a sine, but I guess not. Right? And this is 5, and this is 10. So we see that the beginning amplitude in front of the sine is a cos phi. So 5 equals a cos phi, and 10 equals a sine phi, right? So yeah, we can do this. I can say 10 over 5 equals a sine phi over a cos phi. So 2 equals tan phi. So tan inverse of 2. Tan inverse of 2 is, I want it in radians. Tan inverse of 2. Oh, never mind. It's not anything nice, but whatever. I got, in radians, I got 1.01. No, 1.11 equals phi. I understand there's multiple phi's we can have there, so maybe I should have dealt with that last. Whatever. I don't really know how we would decide which phi to use. Yeah, how would we decide? Okay, because tan has CAST. So tan is positive here and here, so I got, yeah. I can also do, so that's my reference angle that I just got, 1.11 radians. I can also go to the third quadrant, which would be pi plus that. So pi plus answer. So the other answer is that it could also be 4.249 radians. Not quite sure how we decide which one, though.
Yeah, I don't think it matters. I think if it's a multiple choice question, then they would give us one of those two answers, right?
Probably, yeah, probably. That's true. And
Actually, they'd probably give us both, because that happened on the last one.
yeah. So how do I don't know how we decide this one.
So would one of them be unreasonable to say that it would?
Let's see what the answer is. I can do it with Desmos. I can see what the answer is. If I just go, if I plot them both, I say f of x equals. Oh no, I can't. Well, I can do it for fixed t, for a fixed t. So I'll fix t equals 0. So it's just 5 sine 2x. G of x is 10 equals 10 cos 2x, and then we want h of x equals f of x plus g of x, and so that's this. Then I want to know.
Are they all hitting the y-axis at the same point? All three of them?
No. The first two, the last two are g of x and h of x are.
Okay.
But not the other one. Well, so what we can just do
at that point.
What we can just do is just use one of these phi values. So the solution is in the form. I lost the thing here. The solution is in the form a, but a doesn't really matter. So let's say, I don't know, y of x equals, I don't think I can say y of x, let's say a of x equals a sine, for, it was just 2x, yeah, plus some phi, and the phi's that we chose were, come on, I can't.
1.11 and
1.11. Okay, let's try that for
try
sine
that
A.
one first.
So I'll just make A look like it's about the same size, and yeah, that looks right. I mean, it's matching the green one. The green one is what we care about, right? The green one is the sum.
Mm-hmm.
So yes, that's matching. And the other one was 4.2. I have it on my calculator. 4.25, which notably doesn't match and is out of phase. Right?
So basically, Desmos, we gotta hit that up.
Yeah, I don't know. Like, this is how I'm doing it now. I don't know how I would do it later. I don't know how I would decide what the thing is in this case. Otherwise, because we don't get any other information about like the physics of it. Although we shouldn't have to actually. It's definitely just one of the two. Okay, well, choose the first one. I guess that's what you do for this one, because there's no other information, so you choose the first one. And yeah.
Wait, but if you look at it, one of them's completely constructed, the other one's exactly out of phase by pi, right?
Here?
So it's either well, if you look at the resulting one.
The resulting one?
H of x and a, right?
And a?
You can just
and then
subtract them.
If we do use the second one, it's perfectly destructive. It's out of phase by exactly pi over.
Yeah. By half a phase, yeah.
Mm-hmm. So, would that mean anything? I don't know. I'm just
well, that's a way to check. That's a way to check. I mean, you know, you can just check like one way to do it is to I guess just assume some value for A. Doesn't really matter. Assume some value for A, and then
By the way, who makes the midterms? Is this Springer or Duplicate?
Both of them.
I think
combined.
both.
They
Yeah.
do it together.
Okay, anyways, we can solve for A now because we know that phi is that. So phi is this answer. So now we just solve for A by whatever method. I mean, we can just take the first one and I'll just say 5 over cosine 1.11 equals A. So 5 over cosine 1.11 is 11.24. And we have it there. Okay, so yeah, that's that. And that's pretty much it. That's 49. So we just have 43 technically left. But I do want to take a break before we start the test. So I think that's more important, that we take a nice break before we start the test. Let's just see what 43 is, in case anybody wants to look at it. I'm not going to do it.
Can you scroll up once again?
Yeah. Let me just get that. Yeah. To here? Or
Okay, thank you.
higher? Yeah, that's good.
Yeah, not even my answer thing says why they chose the first angle. They just here's like they
They
do
just
the
choose it.
calculation and done.
Yeah.
So I guess I don't know.
I don't know.
Maybe it's
either.
because none of them have a phase angle to begin with. Like they both start positive or going positive, I guess.
Yeah.
I don't know.
I get. Yeah. Go for it.
What was your answer for the amplitude?
11.24.
How'd you do that?
Let me just see if that's right. Yeah, well, 11.18 for some reason, but well, I just took this equation and rearranged it for A. I could have taken this one too. It would be the same.
Okay. Thank
Right. I just know that that's here. Yeah. No problem.
I got one quick question just about escape velocity.
Yeah.
So you know how the equation is 2gm over r, all square rooted?
Yeah. Let me put it on the screen quickly. But yeah, I know. Just get it.
Yeah. So that mass, that would be the mass of the planet, right?
Yeah,
Or
that's
like
the mass.
source?
That's the mass of the source. Yeah.
Okay. All right. Sounds
Yeah.
good.
It does actually. The mass of the object is not important.
And the radius of the source, yeah.
And that's the radius of the RI. Yeah, that's the radius of the source. That's the radius of the source.
Including like radius
The-
of the Earth or whatever.
Yeah.
I'm assuming it's radius from center to center.
I thought that mass was the sum of the mass. The masses, both like the sun and whatever's trying to escape from.
No, because it comes from that. It comes from this equation here. So it comes from the fact that we say the final radius. If you throw something in the sky, the final radius will be evaluated by this. But if this is true, right, then it won't come back. If this is true, if this value, if this bottom value is negative, it won't come back.
So that big M is
So-
the mass of the sun.
Of the source.
The source would be the thing it's trying to escape from.
Yeah, like the planet, or the thing that's causing the gravitational field.
Is R the distance from the middle of the Earth to the height at which it's being launched from?
Yes.
Yeah.
Okay.
So wait, so this R is just its initial launching position. It's not like
It's RI.
it's not. It's a, yeah. So it's just RI. Okay. Just initial launching position. So
Yeah.
whatever.
Yep.
Either from like the surface of the Earth or like a mountain.
Yeah.
Okay.
Exactly. Whatever you're launching from. That's right. Okay, guys. Well, it's 9:41, so let's take a break before we start the test.